The next reaction is you see the ketone, you have an ester here. We put in the basic conditions. Then you need to figure out what's going to happen first. I hope you remember that this hydrogen, I mean, of course, there's no alpha hydrogen on the ester, so that basically limit, you're not going to make a enolate from this ester. But even though this is not that ester, even though it has an alpha hydrogen available, hydrogen on the ketone is more acidic. So base will pick up this proton very easily first. So you make the enolate from the ketone very preferably. And then that's the one that will for the reaction with the carbonyl of an ester. So that's Kleisen condensation. These enolates makes an attack to the carbonyl of an ester. So you get the tetrahedral intermediates, and then it has an carboxyl groups that can be kicked out. So you get the double bond forms, carbonyl created, and by kicking the esters out. So you get the acylation done at another position, which is basically Kleisen condensations. Or we call it crossed Kleisen, mixed Kleisen, but it's just the same. Different name for the same reactions. All right, so I hope that you understand why things go this way, why that one doesn't attack that one. I want you to figure out why things are happening in this particular way. All right, the next one is you have acetone used with the base. I probably suggest you get rid of numbers because these should be put together, not separated out. I made a mistake there. Base will come pick up the proton, and then that will make an enolate. When enolate, see the alphabet unsaturated ketone or ester, doesn't really matter. That alphabet unsaturation done to the carbonyl of the ester, carbonyl of the ketones, that doesn't really matter. Then what we expect is, yeah, we can expect it may go after the carbonyl directly, but that's not going to happen. Most likely, what's going to happen, this one could attack the beta positions of the alphabet unsaturated system. Then you get this one forms. Then this electron pairs comes in, make the ketones, the carbonyl, and that pick up the proton in the water or or the alcohol. Then you get the microvision done. We just made a bond between these two. So if you kind of forget about it, what mistake you would make it is this attack carbonyl directly because you've been seeing the carbonyl getting attacked by the nucleophile so much. Like Grignard, we always make the carbonyl go for the carbonyl, the Grignard go for the carbonyls. So if that attacks there, then you get the alkoxide, this tetrahedral intermediates is coming back and kicking this out, then you get this acylation done at the alpha positions. But this is not what is shown. That's not what you get. You get this. Because the enolate is very soft and nucleophile, but it does microvision preferentially, not the 1-2 emissions. So 1-4, which is the microvision, that's where it goes.